Okay, so we're finding the general solution, so basically just the antiderivatives here. So number 8, dy dx, nope, dt, this one's in t, equals the cosine of t times e to the sine of t. And I need the antiderivative of that. It's not as hard as it looks like it's going to be.
Oh, yeah, I understand. One moment.
We're holding.
Genius think.
Virginia Josh wants you to have this one.
So, I'm guessing e to the sine of t.
Yep, e to the sine of t.
Let's see.
Yep,
Almost
good.
forgot that.
I figured you were going to get it. I'm going to erase this up here because I feel like that's looking really confusing about that problem, but that problem ended at plus c.
Yeah, I was thinking about that yesterday, like.
I was like looking back and I was like, what in the world?
Yeah.
But yeah, this one, because e to the sine of t is just e to the sine of t, and then the derivative of sine of t is cosine of t, so that's why.
Yeah.
That's that. That's why I said the first time I did this problem last year, I tried to do u substitution to demonstrate it, and then I was like, this is too confusing. I was like, we don't need that. So I don't do it that way anymore.
Yeah, I was thinking, is that product rule? No, it's not product rule. And then I remembered how the e's work. Does that say dy du?
Yeah.
Oh, the other one is dy dt. Okay.
Yeah, I said
dt dx for number 8.
dt dx. Yeah, it's not that.
I thought that's what you said.
Well, I said dy dx, and then I said, I mean this one is t, so I was like dy dt.
Yeah.
Guess you didn't catch the ending of that one.
Yeah. Is that a cookie point for you?
Yeah. Loss of cookie point for y'all.
Oh, no. I think you should keep track of your cookie points, and then we have to bring cookies for you.
Virginia already brought cookies for me.
I can bring cookies for you.
Friday.
Oh, right.
Those Post Malone cookies or whatever. No, you said the dark chocolate one. Virginia said the Post Malone ones.
So, sine of u to the 4th. Let's see.
I was right to write son.
What sine of me to the 4th is.
Yeah, I was about to be like, son you, and then I was like, wait, that's not right. All right, so those were the general solution.
I
Now,
love chain rules.
these ones say solve explicitly.
Girl, what?
Solve the initial value explicitly. So all they're doing is they're giving us values to plug in for x and y to solve for c, basically. And then we rewrite with the constant that would have been used in that problem. So,
More work.
12 dy dx equals 2e to the x minus the cosine of x when y equals 3 when x equals 0. So the very first step will be exactly like what we did in the first few problems. So what would the antiderivative of this be?
I feel like it shouldn't be 2e to the x. I also feel like it should be. And then that's minus sine of x plus c.
Yep. So now this is where the point of the problem gets different. The next thing we do is we solve for C. I'm going to make this note here for Virginia. Solve for C, then plug C into this equation so that we get it out. Basically, we're figuring out what C is and then rewriting it so that we knew what C was. So now 3 equals 2e to the 0 minus the sine of 0 plus c. So 2e to the 0 is just 2. Minus the sine of 0. What's the sine of 0?
0.
Yep, so plus c. So 1 equals c. So then now we rewrite this. Y equals 2e to the x minus the sine of x plus 1, and that is the exact value. Or the explicit value. dy dx equals 5. I was about to write second squared. That's embarrassing. Secant squared of x minus 3/2 square root of x. Y equals 7 when x equals 0. They're being so nice giving us x equals 0.
Yeah. A little too nice. One moment. So y equals 5 tangent of x minus x to the 3/2 plus c.
Yep. I know, I had to rewrite this in order to figure out what this was supposed to be. I was like, okay, it's 1/2, so that'll make 3/2. Oh, that's just minus x. I was like, to register what it was. All right, so now we plug in. So 7 equals 5 times the tangent of 0 minus 0 to the 3/2. They're being so nice. Tangent of 0 is what? 0 minus 0, so c equals 7. So then y equals 5 tangent of x minus x to the 3/2 plus 7. At least this stuff isn't like hard. Thinking about the derivatives, it's like, or like the antiderivatives, I guess. That's kind of the hardest part, but 18 dx dt. Yeah. That's what you tried to do earlier. I think you did dt dx though.
Yeah.
1 over t minus 1 over t squared plus 6. And then it's x equals 0 and t equals 1. They're just on a roll with this x equals 0 thing today.
So, I guess ln of t plus t to the negative 1 plus 6 t plus c.
Yep.
I forgot the x equals.
Well, I knew
forgot
what you
to
meant.
state that.
I was about to write y, and then I was like, oh wait, this one's x, and then I was like, I would have figured that out eventually.
Yeah, I meant to say x equals, but then I just went straight to ln of t, so.
So then we just plug everything in. What's the ln of 1?
0.
1 to the negative 1 is just
1.
6 times 1 is just 6. So I've got 0 equals 7 plus c, or negative 7 equals c. Oh no.
Oh no. Oh goodness. How did that happen?
Went all the way up to the top. So x equals ln of t plus t to the negative 1 plus 6t minus 7. Was gonna be done on that one, but this next one is a good one, so. All right, ds dt, Josh's favorite, t times 3t minus 2, s equals 0 when t equals 1. So the first thing I would do would be distribute, because it'll make it easier. So ds dt equals 3.
I was thinking it was some sort of chain rule thing.
Well, that's why I was like, some people have tried to do that before. That's why I was like, this is a good problem. So 3t squared minus 2t. Now we can take the antiderivative.
T cubed minus t squared plus c.
Yep. So now we plug in. 0 equals 1 cubed minus 1 squared plus c. So 1 minus 1 is just 0. So 0 equals c. So then at this point, a lot of times I may go back up here and just say c equals 0. And then at the bottom, where I would normally write my final answer, I will have s equals t cubed minus t squared. Because obviously there's been several derivatives we've taken that haven't had a constant, so it's not surprising. But I don't need to write like plus 0 down here in my answer. I'm just noting up here c equals 0 from what I found, so that I'm aware that I didn't just forget to do a step or something.
That's smart.
Now, if you've already shown down here 0 equals c, it's not necessarily a big deal to come back up here, but at least with your final answer, it's good to have that all kind of together.
Yeah.
All right, so the next thing, I'm trying to see, is it in this section or is this just review? Maybe it's just review. Guess it's review. All right, so we had the fundamental theorem before. It's just been a while since we used it. It's the integral from a to x of f prime of t dt.
Oh, back to intervals. I was wondering when those would come back.
So f of x minus f of a. And so then we also had another way is f of x equals the integral from a to x of f prime of t dt plus f of a. So these next two problems say, to solve the initial value problem using the fundamental theorem, your answer will contain a definite integral.
So, question. Does the dt thing kind of end the integral?
Yeah.
Okay.
It's almost like a grouping symbol. I mean, it's not technically, but it kind of like, is what finishes off that piece of the
So
problem.
So that's why the plus f of a thing is,
Like, separate.
yeah, and like we can subtract it to
Yeah.
f of x thing, get the other thing.
Yep.
Okay.
So this will be the form we're about to write our answers in here. So we've got 22. Of course, they're using different letters. Du dx
Bruh.
equals the square root of 2 plus cosine of x. U equals -3 when x equals 0. So whatever this u value is here, because that's what we're taking it with respect to, is f of a. So f of a equals -3 here. So if it was like dy dx, then whatever the y value is would be that, f of a. So now all we do is the throwback, because we've done this before, but f of u equals, I knew it was coming, 0 to x, so 0 is that a value, of, we replace x with t, remember we use t with these problems, so the square root of 2 plus the cosine of t dt, and then -3 from that f of a. And that's all we have to do on those ones.
I forget which section of notes this thing I'm thinking about was in, but there were some formulas that did not look very polite. I did not like the
I think
order.
it might have been 7.2.
No, it was something in chapter 6.
Oh, something from the past.
I think there was an F somewhere, there was a K somewhere, and a U somewhere, and they were in a certain order.
Wow.
And I did
That might
not-
have possibly been on one of the tester quizzes.
Oh, it was in the notes.
Oh, okay.
I did not like the way it was looking at me. Also, is that a G?
Yes.
It has a hole in it.
My G always has a hole in it.
Oh, it looks like one of those circle arrows.
Yes, my G's always do that because I don't like connecting them. Then they look weird.
Oh, I always just go around in a circle, and then once I get to a certain point, I just go straight in.
Josh be like, "Yeet."
Yep.
That looks like a 6.
Well, I guess that's now another thing to get confused with, because my B's already look like 6s. Or my 6s look like B's, I don't know which one it is. Also, my 5s apparently look like 6s, I don't know who thinks that, but some people do.
5s look like 6s. Daniel's 9s look like 4s.
I've seen
Or
people
vice versa, I can't remember.
I've
His
seen
4s look
people
like
who-
9s.
who, like, will
But his
write
9s?
9,
Daniel's 9s look like this.
that's a G. That is literally a G.
It's like, or it's like this.
Like, buddy, you are not a digital clock. Okay?
So, and then his 4s are like this, I think. So I struggle sometimes because I'm like
Is-
9 or 4. I have to go compare it to something to make sure.
It looks like it has like a pizza slice on it.
I mean, I used to do my 4s like this.
Okay, now that's just a flag.
Like, I used to do mine like that, which I think is what he's doing. They're just curvy instead of, like,
Straight.
yeah. Anyways. Okay. So G prime of S is another way to write the first, like, this, obviously. We've had the different notations before. So this is going to be...
So is that like GDS? GSDG?
DGDS.
GDD.
Josh is glitching. DGDS.
DGDS.
So this up here, S is 0, G is 4.
Why'd you write it in that order?
I don't know.
Why not write the S under the 0 and the G under the 4?
Because I wrote G equals.
Right.
Okay. Anyways, the integral now from 0 to x of the cube root of the tangent of t dt plus 4. And that's it on that one.
I like the way tangent of t looks. It just says tant.
Okay.
Imagine if there was a tangent of t.
Yeah.
It'd be tant.
All right, so the next thing that we've got coming up is slope fields. So a slope field
Oh no.
looks something like that.
Can I run on it?
So, anyways, these are what slope fields look like, and at each point we basically draw a little line of like 1 unit of what the slope of that spot would be doing. And then we can connect what's happening with these lines. Virginia, we're looking at page 328 if you want to look at it later. So anyways, but we're looking at what's happening at each spot as we go. And so then you can take and you can draw your curve based on where you are on how it should look, even if you don't know what this is supposed to look like. Our differential equations.
They
So,
seem like it seems like it would be very hard to keep track of which thing you're supposed to go with.
it can be.
Because I'm sure I would end up like on that last one that you showed me. I don't know. I think I would just go like up when I'm supposed to not start going up, or I would just keep going straight.
So we do it at each individual point. So basically, I'm going to actually put up a little piece of graph paper here so that we can see it.
Should I get out a piece of graph paper?
That's up to you. If you want to, you can.
Would it be useful?
Possibly.
Okay.
Oh, not that color.
It's two. Just wanted one piece of graph paper.
All right, so basically, I made this bigger than it needs to be, but 1, -1, 0, 1, 2, and down to -1. So they give us this little graph here, and we're finding the slope field for the differential equation given to us. So basically, we're going to use this one slope field, and each problem will have its own. So from at each of these points, I'm going to draw the slope of the line here. So I'm going to have 12 points that I'm doing this for. Now, we can do it obnoxiously large, but it's really annoying, and we don't really need to be able to do that. If you can do it on a small scale, you should be able to do it on a bigger scale if it was needed. Usually some multiple choice questions, or could be a short answer question that involves this.
Okay.
Yeah, we're going to do a lot more with this than what we're just now about to do. So, let me, looking at how much time we have, if I have time to get through all of this or not.
We have 6 minutes.
So, basically, I'm going to look at example 6 here really quick. Essentially, we've got here, it says to construct a slope field for the differential equation dy dx equals the cosine of x. So we're going to do one that dy dx equals y, and then dy dx is equal to like 2x minus y or something like that. Anyways. So we know that the slope at any point 0 comma y will be the cosine of 0, because if I plug in 0, I get 1, right? Because the cosine of 0 is 1. So anywhere on the y-axis, it's going to have a slope of positive 1. A lot of times when I get into the ones that are harder, I actually will make a little table. Then, let's see. Since the slope at any point pi and y, or negative pi and y, is negative 1, at any increment of pi or negative pi, I'm going to draw a little slope of negative 1. And it's going to be going down. So I think, where is it? Over here. So they've had our positives here on the y's, or I mean on the pi's, they're going down. They're little negative slopes. So then we can draw the tiny segments with slope negative 1, blah, blah, blah. The slope at odd multiples of pi over 2 will be 0, because the cosine of pi over 2 is 0. So that means that here at the pi over 2's, we have 0 slope. So their slope's going straight across. And then finally, we had tiny segments of slope 1 along the lines x is plus or minus 2 pi, because basically this is going to keep alternating over essentially at 0, at 2 pi, and all of that's going to be positive 1s. And so they're going to alternate so that we ultimately get to this down here, and I can draw the graph by following one of those slope fields, and it'll end up graphing, in this case, a trig function. And I'm planning on us watching one of the AP videos about this for them to give us a better idea of what you actually need for the AP exam to make sure that we're good. We actually may do that next period in calculus and physics. So maybe what we start with after we do the last slide of that. Anyways, so basically, if I had, we'll quickly do number 30, and then we'll do that when we come back. So 30 is dy dx equals y. So anywhere, basically, we're just plugging in numbers. So if I plug in like 0 here, what do I get for y?
So when dy dx is...
Yeah, so like if this is, so like here, this point is 0, 0. This one's like actually super duper easy. So that means that if that's 0, it's 0. So this one goes straight across. Here, y is still 0. So that's also 0. Over here, in negative 1, or negative 1, 0, it's still 0. So it's going straight across. At positive 1, that's at a y value of 1. So it has a slope of 1. Over here, slope of 1. Over here, slope of 1. Then up at 2, the y value is 2. Up here all the way across. So it's a little bit of a steeper slope. And so all of those going across. And they won't obviously always be this way. That's why I said we're going to do one with a table. This one's just ridiculously easy. And then down here at negative 1, so when the y values are negative 1, they have a slope of negative 1. So then I just do them like that. And that's all you have to do on these problems that are asking you to draw the slope field. Now, there's other things that slope fields can tell us, and we'll use to do those things, but for these, it's just typically drawing one. And if it's in a free response question, at least the ones that I'm recalling right now, they just ask you to draw one on like a plot that looked like this, basically. Or if it was in a multiple choice question, they gave you some and said which one is the slope field for this given equation. So they're not actually that hard, they're just really annoying. But we'll start with 32 when we come back, and then we might finish this stuff up later. We will see.